Alright, ladies and gentlemen, we are going to do a couple problems of 05 HW1, variables on both sides. What we have in front of us is problem number 1, 8v minus 3 equals 7v minus 7. Notice here we have v's on both sides of this equal sign. We have an 8v here and a 7v here. Now, with variables on both sides, we can move around terms from one side of the equal sign to the other side of the equal sign. Just like how we move around our constants, like with our numbers on both sides when we're using our first learned about inverse operations. So that's what we're going to do here. I'm going to move this 7v over to the other side of the equal sign. So I look at the 7v. The 7v, that's a positive 7v, because there's the imaginary plus sign there. So the inverse operation of positive 7v is subtract 7v from both sides. So I subtract 7v from underneath the positive 7v. Now I'm going to subtract 7v and put that underneath the 8v, but not underneath the negative 3, because it has to be subtracting of like terms. The 7v has to go underneath and be subtracted from the 8v, because both of them are at v to the first power. So we subtracted 7v from both sides of that equal sign. 8v minus 7v gets us 1v. Carry down the negative 3. Carry down the equal sign. Positive 7v minus 7v, they cancel out. And we carry down that negative 7. So we subtracted 7v from both sides of the equation. We simplified it. Just rewrote the equation to rewrite. Then we're going to add 3 to both sides. So it'll be v equals, well, negative 7 plus 3 gets us negative 4. Both sides. And then we have our solution. So v equals negative 4. And that's the answer in number 1. Next up is problem number 3. Now this is problem number 3. Here on our homework worksheet. We have 2 plus v equals 1 plus 2v. Now, notice we have a v on both sides of this equal sign, known as variables on both sides here. Now 2 plus v, well, you know that's a imaginary 1 in front of that v, so it's 2 plus 1v. Equals 1 plus 2v, and that's given to us. Now, I'm going to move this 1v over to the other side because the 2v is a little bit bigger. That's just my preference, so I'm going to move that 1v to the other side. So the inverse operation of plus 1v is subtract 1v. Now I'm going to put that subtract 1v underneath the 2v because we have like terms here. I'm not going to put it underneath the 1. Because these are the 2 v's to the first power. So we have 2, we carry down the 2. 1v and negative 1v, they cancel out. Carry down the equal sign. We have 1 plus 2v minus 1v gets us 1v. So we subtracted 1v from both sides of the equation. We simplified it, made it look nice and pretty. Then, there's an imaginary 1. Imaginary plus sign in front of that 1, pardon me. So, inverse operations, subtract 1 from both sides. 2 minus 1 gets us 1. The 1's cancel out, and we carry down our v. So we have v equals 1. This is subtract 1 from both sides of the equation. And then, solution. Of v equals 1 for problem number 3. Next up, we're going to do problem number 5. Alright, right here we got problem number 5. We got 1 minus 2r equals negative 2 minus 3r. Then we have variables on both sides of that equal sign. So, when I look at this problem, I'm going to want to move this negative 3r to the other side, because I know negative 2 plus 3 is going to get us a positive 1. That'll try to avoid some of these negatives here, get rid of them. So, I'm going to add 3r to both sides of this equation. Notice how I put the 3r underneath the negative 2r because they're like terms. I don't put it underneath the 1 because I'm only really adding the 3r to the negative 2r and not really the 1. So we carry down our 1. Negative 2r plus 3r gets us a positive 1r. So I'm going to not even bother to write the 1, just going to do 1 plus r. Because that 1 is not really needed. So 1 plus r equals negative 2. And negative 3r plus 3r, they cancel out, get you nothing. So I don't bother writing anything. So we added 3r to both sides of the equation. Then we use our inverse operations. We know this is an imaginary plus sign in front. So positive 1, subtract 1 from both sides. Positive 1 minus 1 gets us 0, so we don't write anything. Our positive r, well, that's really just r, equals, well, negative 2 minus 1 gets us negative 3. So our answer is r equals negative 3. From both sides, and we have our solution of r equals negative 3. Next up is problem number 6. Problem number 6. Alright, here's problem number 6. We have negative 5n equals 4 minus 7n. That's given to us. What we're going to do, looking at this problem, since negative 7 is bigger than negative 5, it's further away from 0, I'm going to actually move that negative 7 over to the other side to help make it more positive numbers. So the opposite of negative 7n is add 7n to both sides of the equation. So add 7n to both sides. Negative 5n plus 7n gets you 2n. Carry down our equal sign, carry down the 4. Negative 7n plus 7, they cancel out. So we have 2n equals 4. I just rewrote it, make it nice and pretty, simple. 2 times n equals 4. The inverse operation of times 2 is divide by 2. Times 2 divided by 2, they cancel out, so we get n equals, well, 4 divided by 2 gets us 2. This was divide by 2 to both sides of the equation, and then solution. N equals 2. And that's the answer to number 6. Last problem we're doing is problem number 9. Alright, this is problem number 9. We have negative 3k minus 6 plus 6k equals negative 6 plus 7k minus 4k. That's what's given to us. So we're going to write given. We're going to combine like terms. Negative 3k plus 6k gets us 3k. The negative 6, there's no other like terms on the left side of the equal sign, so we rewrite it down here. So we have 3k minus 6, because these are our two like terms that we combined. Then we have negative 6 plus 7k minus 4k. Well, that negative 6, there's no other like terms on the right side of the equal sign, so we just carry down that negative 6. Our two like terms on the right hand side are positive 7k and minus 4k, so 7 minus 4 gets us positive 3k. This was combined like terms. So notice in this problem, it wasn't variables on both sides where we use our inverse operations first. This problem, we use combined like terms to make our problem smaller. Now, 3k minus 6 equals negative 6 plus 3k. What we're going to do, let's subtract 3k from both sides. Positive 3k minus 3k gets us 0k, so we write nothing there. Carry down our negative 6. Negative 6, carry down. 3k minus 3k, that gets you no k. Well, we have negative 6 equals negative 6. Now this is one of those unique situations. When a number equals the exact same number on the other side, that means we have infinite many solutions, or all real numbers, for our answer in this particular problem, number 9. So our answer is all real numbers. And what I want you to do in that Google form is just write out all real numbers. And you'll get credit for problem number 9. It's one of those fancy ones. Beware, problem number 10 is also another fancy solution.